In this section, we're going to work on animations and create a set of animations for the tank in Unity. The good news is that here we'll also cover animation layers in Unity, which can really help us in many games. So follow along with me. Select the player blue object and add it to the scene. Then go to Window menu, open the animation window in Unity, and pin it here. While tank free blue is selected, click the Create button to create a new animation. In the window that opens, create a new folder and save this animation in that folder. Now in the animation window, click the Record button. At frame 0, change the Z rotation slightly to create a key. Then set it back to 0. Next, go to frame 2 and set the Z rotation to minus 0.2 to create another key. Go to frame 4 and change minus 0.2 to 0.2 to add another key. Then at frame 6, reset this value back to 0 to complete a full loop. Now select the keys at frame 6, 4 and 2, copy them and paste them at frame 8. Repeat this a few times. Keep in mind that the first key you select is considered the base, and it automatically selects all the keys below it, so there is no need to select every single key for copying. I think that's enough, and we don't need any more keys. Now stop the record mode and click play in the animation window. Click on this combo box, select Create New Clip, and create another animation in this folder called Move Forward. Now go to the idle animation, select and copy these keys, then select Move Forward and paste the copied keys into this clip. Next, select all the wheels and click the record button. At frame 0, create a key for the x-axis rotation. Then, while still in record mode, go to frame 60 and set the x value to 360 to complete the move forward animation. Next, we create another new clip called Move Backward. Go to the idle animation, copy all these keys, then select Move Backward and paste them here. Now click the record button, select all the wheels, and create a key for the X rotation at frame 0. Then go to frame 60 and set the X value to minus 360 to create another key. Stop the record mode and click play. Now if you notice, the rotation for the wheels isn't what we want. So stop the animation, select these keys, and click on Curve. With all the keys selected, right-click on one of the keys and choose Linear from the Both Tangents option. We switch to dropshift mode and click play. You'll see that the previous issue is gone and the move backward animation works correctly. We stop the animation. Next, we need to do the same for move forward. Select all these keys, go to Curve, and press the F key once to frame all the keys. Then, right-click on one of the keys and choose Linear from the Both Tangents option. Now, if you play the animation, you'll see that the wheel rotation issue is fixed here as well, and they rotate at a constant speed. Next, click on Create New Clip and create another animation called Turn Left. For this one, first go to Idle, copy all these keys, and then paste them into Turn Left. For Turn Left, rotate the right wheels clockwise and the left wheels counterclockwise around the x-axis. This way we set the keys for the wheels accordingly. Just like before, we select all the keys again, go to Curve, and choose Linear for the tangents. In this part, click Create New Clip again and create another animation called Turn Right. In this animation, we do the opposite of turn left. The left wheels rotate counterwise and the right wheels rotate clockwise. Next, go to Idle, copy the keys and paste them into Turn Right. Then, as explained before, at frame 0 set the left wheel's rotation to 0 and at frame 60 to 360. And do the opposite for the right wheels. Just like before, select all the keys, go to Curve, right-click on one of the keys, and choose Linear from the Both Tangents option. Now, if you play the animation, you'll see that it works correctly and it effectively simulates the tank's neutral turning. Stop the animation and click on the combo box again. In Create New Clip, create the fire animation. This animation will be for the bullet firing effect. First, select Tank-Free Channel and click the Record button. At frame 0, create a key for the Z translation. Go to frame 4, move the Z translation back slightly and create another key. Go to frame 6, copy the key from frame 0 and paste it at frame 6. At frame 12, paste the frame 0 key again. Stop the record mode and click play to test the animation. It seems this animation is working fine as well. So we stop it and continue with the next steps. Go back to the project, select the tank-free blue object, and in the animator component choose the animation controller. We rename this object to tank animator. Double-click the tank animator controller to open it in the animator window. Select the fire animation and uncheck the loop time option, as this animation should only play once. For the idle, move backward, move forward, turn left, and turn right animations, make sure the loop time option is checked. Right-click on any state, choose Make Transition and then connect it to the fire animation. Create a transition from idle to move forward and vice versa. Do the same for the other states as well and creating transitions between them. In the parameters section, create a few new parameters of type bool that will be used to control the different states. Since we don't need this transition here, we delete it. Now select the transition, click the plus button, choose the move backward parameter, set it to true, and uncheck the has exit time option. For this one, select the turn backward parameter, set it to false, and also uncheck the has exit time option. For the remaining states, do the same and select the corresponding parameters for each case. We'll create a separate layer for this state later. And for now, we'll leave it as is without any further changes. Select the tank-free blue object, create a new script called Player Animation Controller, and add it to the object. Then open it in Visual Studio. In this script, we create a variable of type animator with the same name and reference it in the await method. We define a method called playMoveAnimation with a speed argument. Inside this method, we first check if the speed is greater than or equal to 0.01. If this condition is true, we call setBool, passing moveForward as the first parameter and true as the second. If a speed is less than or equal to minus 0.01, we call setBool again, but this time passing moveBackward as the first parameter and true as the second. In the case where speed equals 0, for the setBool method, we set the second parameter to false in both cases. We use the same method for the turn parameters, just changing the names. So we copy this method, paste it here, and update the method name and parameter titles accordingly. Next, we define the playFireAnimation method and directly use the play method in the animator to play the fire animation. Save the script and return to Unity, then select the tank-free blue object. Since we've added the new animator component to this object, and we want these animations to sync over the network later, it's necessary to add the Photon Animator View component to this object as well. After adding this component, you'll notice that all the parameters used in the animator are listed in the Photon Animator View component, but they are initially set to disabled. This prevents these parameters from syncing over the network, so we replace the disabled value with discrete to enable syncing. We go to the Scene tab, select the Player Blue object, and click Override to apply the changes to the Player Blue prefab. Then we open the Player Controller script in Visual Studio. In this script, we create a reference to the Player Animation Controller script and define an accessor with the same name. We go to the update method, and after assigning values to the move input value and turn input value variables, we call the player move animation and player turn animation methods for the player animation controller. So the player can use these animations. Here we also call the play fire animation method for fire. We copy this line and paste it in the mobile fire method. Then we return to the editor. While player blue is selected, we assign the player animation controller field. We select player blue again and click Override to apply the changes to the subject in the prefab. Now we can remove the subject from the scene and run the game once. You'll notice that the train slope is not being detected. Now let's check the bullet firing animation as well. It seems this animation works, but if you pay attention, since the animator doesn't return to the default state after firing, it ignores all other animations even after firing a bullet once, and the firing animation stops working for subsequent shots. Now if you select hand-free blue, you'll notice that after the fire animation is played, the animator stays in that state and essentially stops working. A solution we could offer for this issue is to use a coroutine. So after the fire animation plays, we play the idle animation after, for example, 1 second. However, the problem with this approach is that if we use this coroutine for every bullet shot, it will not only affect the game's performance but also cause the idle move and turn animations to have interruptions, which itself creates more issues. A second solution we can propose is to use animation layers and create a separate layer for the fire animation. This way, the fire animation will always play simultaneously with the base layer, and there will be no need for extra work. We will now work on this solution, which is actually the correct approach. We stop the game for now and go back to the scene. Then in the resources folder, open Player Blue in the prefab editor. And select the tank-free blue object. As we mentioned earlier, by using Photon Animator View, we can sync all the animation parameters in the game by setting them to discrete. However, for syncing methods like play, which execute an animation, there is no direct way, and we'll need to use our PC calls to sync these methods across the network. But before doing that, we go back to Unity, switch to the Animator tab, and work on the second solution proposed here to fix the bullet firing issue. Now we go to Layer section and create a new layer called Firing Layer. We copy this animation state and paste it into the new firing layer. And then click on the layer settings and set the weight to 1. Here right click and create a new state and then set it as the default state. We create a transition from the fire animation to this new state. Select the transition and make sure the has exit time checkbox is checked. By doing this, we've ensured that this layer runs alongside the base layer, and we won't face any issues with firing anymore. In fact, every time the fire animation is called in the player fire animation method, after executing this state, it will return to the default state through this transition. We go back to the scene and run the game once again. As you can see, there is no longer any issue with the bullet firing animation. By defining an additional layer in the animator, we've solved this problem. We stop the game and then we'll proceed to test the multiplayer functionality. Now if we place these two tanks next to each other and fire as before, you'll notice that unfortunately the fire animation is not syncing between the two clients. This is because, as mentioned earlier, we haven't yet used RPC calls for the player fire animation method to sync it across the network. So we stop the game, open player blue in the prefab editor, and select tank free blue. Up to this point, by setting the value to discrete for the parameters in Photon Animator View, we've been able to sync the parameters used in the setBool methods in the player animation controller script. However, for syncing this method playFire animation, we cannot use the same approach as these methods and will need to use RPC calls. We copy this method and paste it here. Then we add the RPC prefix to the method name and also add the PunRPC attribute to it. Instead of this line, we use the RPC method in Photon View to call the RPC method. Save the script, return to Unity, and test the game in multiplayer mode. As you can see in this run, the firing animation syncs correctly across both clients. However, if we move on the train slopes, you'll notice that there is still an issue with the body rotation not syncing, both locally and over the network. This is due to a conflict caused by the simultaneous use of the tank pitch method and the animator component attached to this object. We stop the game and press it to fix this issue. Then we open the player blue object in the prefab editor. Select the tank-free blue object and create an empty object underneath it, temporarily renaming it tank blue. Then place this object under player blue. If you notice, this creates an offset for this object. Next, select the tank-free blue object and place it under tank blue. Now we need to add some components to this object that were attached to tank-free blue. First, add the Photon View component, and then add the Photon Transform View Classic component. Now we select the tank-free blue object and remove the Photon Transform View Classic component from it. For this object, only the animator will be synced over the network. And for this object, only the rotation will be synced over the network. Next, we select player blue and assign the tank blue object to the tank field. So for tank free blue, we have these components, and for tank blue, we have these ones. Return to the scene and build and run the game once again. As you can see, we no longer have the issue related to the train slope in this run. Additionally, both the animator and the tank's body rotation are syncing correctly over the network. We stop the game, return to the scene, and apply the same changes for the other players as well. Then we open player green in the prefab editor and assign tank free green to the corresponding field. However, we still haven't added the necessary components to it. So we select the subject and attach the animator component to it. For this field, we assign the tank animator controller, and then we add the Photon Animator View component and change the value of all the parameters from disabled to discrete. Select the player green object and first add the player animation controller script to this field. Then we assign the tank free green object to the player animation controller in player green. Now we select the tank free green object, create an empty object, and rename it to tank green. Then we place tank green under player green and set tank free green as a child of the tank green object. Select the tank green object and add the Photon View and Photon Transform View classic components to it. We no longer need this component on the subject, so we remove it. Now we select player green and replace tank free green with the tank green object in the tank field. Next, we do the same for player red without any additional explanation. We go back to the scene and navigate to the tank animations folder. Here we rename tank animator to player tank animator and then duplicate it. For the duplicated object, we replace the name with Enemy Tank Animator and open it in the Animator. Go to the base layer and remove the turn left and turn right animations. We don't need these in the enemy tank. Go to the resources folder and open enemy tank in the prefab editor. Similar to the player, we first select the subject, attach the animator component, and then assign the enemy tank animator object to the controller field. Next, we add the Photon Animator View component and replace the disabled value with discrete for all parameters. However, we no longer need the turn parameters, so we remove them from the animator. We select enemy tank again, and in addition to the two components added, we create and add a new script called AnimationController. Then we open it in Visual Studio. Here we can use the code we wrote in the player animation controller script. So we copy all of these lines and paste them into the enemy animation controller script. However, we don't need the play turn animation method here, so we delete it. We press the Alt and Enter keys to add the photon.pon namespace. Then we save the script and return to Unity. Next, we select the enemy tank object, right-click to create an empty object, and rename it to Tank Yellow. Then we place it under the root object. Next, we select enemy tank and place it under the same object, Tank Yellow. Select the enemy tank object again and remove the Photon Transform View Classic component. Now, similar to the player, we select the Tank Yellow object and add the Photon View and Photon Transform View Classic components to it. Now we select the enemy tank object and open the Enemy Unit Tank script in Visual Studio. We create the enemy animation controller field, copy it, and in the update method, we call play move animation through this variable. And in the fire method, we call the play fire animation method as well. Let's define this field as public so it's accessible in the inspector. Save the script and return to Unity. Now for this field, we assign the enemy tank object, and for the tank field, we also assign the enemy tank object. Return to the scene and build and run the game. It seems there is no issue running the game for the green player, and the synchronization of the tank body rotation and animations works correctly across both clients. We stop the game and finally test player red in single player mode. In this player, fortunately, there are no issues. And as you can see, the enemy tank is also functioning correctly.